The second part of the lab involves investigating isostasy. We'll investigate why oak and pine blocks find different floating levels, different isostatic equilibrium in water. This is a model for the way oceanic and continental crust find different floating levels, different isostatic equilibrium in the denser asthenosphere below. So we're using the pine block to represent continental crust and the oak block to represent oceanic crust, and of course the water, because it's denser, to represent the asthenosphere. And we want to be able to measure what percentage of each block is submerged in water and what percentage is above the water when it floats. So to do this part of the lab, fill the 600 milliliter beaker with water. I found it worked best if I filled it to a level above the white markings. It was easier for me to see. And then I'm actually going to turn the white markings away so it'll be easier for you to see on camera what's going on here for the levels. The problem is when we put this pine block in the water, I'm going to start with the pine block, but it's going to tip. And so I'll show you just a real simple workaround. Make sure the block is dry when you start. I've been fiddling around with this second one and it's gotten wet and it's absorbed water, and I can feel just in my hand that it's much denser. So it's very nice to have the two of them. We're ultimately going to need two. But if you end up fiddling around so much that one of the blocks gets saturated with water, you're going to have to let it dry out and repeat the experiment to get accurate results when this is actually dry. So to figure out the percentage of this block that will float in water or be submersed in the water when you put it in water, put it in. And you can see, of course, that it's floating, which makes it very inconvenient for us to measure the volume. So the way to get around this is just take your metric ruler, make sure you know which is the metric side, and very gently press the metric ruler, press the block against the back of the beaker with your metric ruler. You really don't want to press hard. You're not trying to change the level at which this floats, but this will allow us to keep the block in place and to figure out what percentage is above and below the water. So you guys can't see me. I've actually got my head down so I can look down below the water, and it looks like my pine block is starting at about 9 centimeters and it's going to almost exactly 11. That makes sense because that pine block both blocks are 2 centimeters high. Now I'm trying to figure out how much of that 2 centimeter height is below the water and how much is above the water. And for example, in my simple way of looking at this, it looks like approximately 0.9 centimeters. It looks like I'm going from about 9 to 9.9 is below the water. And from 9.9 to 11, or 1.1 centimeters, looks like it's above the water. And I've given you a simple way in the lab to figure out, therefore, what percentage is above and below the water. You'll do the same thing with the oak block. Probably won't surprise you that the oak block is denser, and therefore a greater percentage of the oak block is going to be submersed in the water and a smaller percentage is above. Remember that this pine block is representing continental crust, which of course is going to float higher because it's less dense than the oceanic crust. In the last part of the lab, we ask you to stack 2 pine blocks on top of each other. So I'm going to get rid of my ruler, or I suppose I could have left it in place to make it easier. Now, what we're simulating here is, for example, a mountain when we've got much thicker continental crust, or even something like glacial ice loading onto continental crust. So you repeat the same procedure. Now we should have altogether about 4 centimeters of block. Now I'm going between about 8 and 12, even though that last one wants to tip a little bit. And I'm going to estimate the proportion that's below the water, the proportion that's above, the same way we did with a single block. What you should find is that we're getting the same proportion above and below, even as this continental crust is thicker. That means that while there's going to be a greater proportion of the continental crust above the sea level, for example, in continental crust, if this were a mountain, there's also going to be a greater proportion of the continental crust below sea level in a mountain. You know that mountains have deep roots.